Hey guys, my name's Ryan. I'm a tutor in the Econ Tutoring Center. Today I'm going to go over an example of finding an optimal demand bundle with an indifference curve and a budget constraint. So remember that these videos are shot live, so if we make any mistakes, be sure to just let us know and we'll do our best to fix them. Okay, so the basic setup here is that we have two goods, goods A and B, and I'll plot good B down here and good A here, right? And we have a budget constraint that represents how much of good A and good B we can consume with a given income and given prices of goods A and B, right? So that gets us this here, and this curve is represented, or this line here, is defined by what I just said, our income constraint, right, which says that the total amount of money that we spend on good A, which is the price of A times the amount of A that we consume, plus the total amount of money that we spend on good B, can't exceed our income, right? So, you know, we can only spend a limited amount of money, and we have to split it somehow between the total amount that we spend on B and the total amount we spend on A. And the second facet to this are these indifference curves, right? And the indifference curves look something like this, and they represent our preferences and how we prefer one bundle to another, right? So if two goods are on the same indifference curve, it means just that we're indifferent between the two of them, right? If one bundle's on a higher indifference curve, say this bundle relative to this bundle, it means that we prefer this bundle to this bundle, right? As opposed to if two bundles were on the same one, then we're exactly indifferent to them, right? And so the goal is for us to get into this high of an indifference curves as we possibly can, given our budget constraint, right? So we can't go anywhere outside of this budget constraint, but we want to be on the highest indifference curve we can. And so what that gets us to is that the indifference curve that just touches this is our optimal one, right? So we want to find this bundle here where our indifference curve just touches the budget constraint. And that's going to find us this bundle right here is our optimal bundle given our indifference curves and given the budget constraint, right? So I'm going to go through an actual example here of finding this point, but that's the general theory behind what we're doing. That the price of A is $10, price of B is $4, and the income is $25,000. First, what we want to do really to find what this this tangent point is, we say, because that's where we say that's where the slope of this indifference curve here is equal to the slope of this budget constraint. So that is exactly how we find this particular point here, or really the set of all points at all incomes, where you're maximizing, you're getting to the highest possible indifference curve that you can, given your budget constraint. So we want to find where the slope of this, we call this the MRS. So the slope of the indifference curve is called the marginal rate of substitution, because it represents how much of good Y you give up to be just indifferent to given a change in good X, right? So if I go down in Y a little bit, how much X do I have to add just to make me indifferent, right? And that is exactly what the marginal rate of substitution is, right? So when this line gets flatter, it means that these two goods are more substitutable, right? So I have to give up just as much X to get additional Y, so maybe 1 for 1 or something. And as they get more bowed, it means that the two goods are less substitutable, right? So goods A and B, I can't give up any amount of B to keep me indifferent to losing a little bit of A. And that's kind of the gist here. And then we want to relate this slope to the slope of this budget constraint here, which is just the cost ratio of the two goods, right? So we want to where the rate at which we substitute good A and B is exactly equal to the ratio of prices between the two of them, right? And that's going to find us this optimal thing here. So we're given that the marginal rate of substitution for the slope of this indifference curve is negative QA over QB. And then we just need to find what the slope of this budget constraint is. And it turns out that that's always, in this setup with QB on the x-axis, that's just going to be negative price of B over price of A. It's negative price of A, I'm sorry, negative price of B over price of A. So the good on the horizontal axis divided by the price of the good on the vertical axis, which is just negative 4/10. So there's a couple ways that you could go about finding that, right? This is just a trick that if you, you could solve this in the form y equals mx plus b and just solve for QA and you would find the slope that way. Another way of doing this maybe would be to find out what these points are here, right? And then just look visually at rise over run and find what that is. So if we did these points, that might be a good thing to go through really quickly. So these points represent if we spent all of our income on B, and this point represents if we spent all of our income on A. So this is just going to be our total income divided by the price of B, which is 25,000 divided by 4, which is 6,250, that's what we call. And this would be 2,500, because it's 25,000 divided by the price of A, which is 10. So if we spent all of our income on, all $25,000 of our income on good A, we could get 2,500 of them, and 6,250 for B. So then I could look at this analytically and say, okay, well, the rise for 2,500 minus 0 divided by 0 minus 6,250, and that's going to get us negative 4/10 as well. So either way you want to look at this, this is how you find the slope of this budget constraint. Okay, so now our goal is to find this tangency point, right? So we want to set this slope equal to this slope, right? Which is going to mean that we have negative QA over QB is equal to negative 4/10 is really negative 2/5. Right, just simplified that. The negatives will cancel here, and we will get QA is equal to 2/5 QB. Right, and really what this gets us, it gets us a line through here of all of our optimal bundles of A and B, right? So for all different income levels. So this just relates, remember, this ratio of prices to these indifference curves and this marginal rate of substitution. Right, and so at any given level of income, we're always going to consume, at these prices, QA in the ratio of 2/5 of QB. Right, so that will always be true. Now what we need to find is we need to find at this particular income level, 25,000, what is this bundle? Right, and so the way we're going to do that is simply by plugging this requirement into our budget constraint here. So I'll do that by plugging in 10, but now QA we know is 2/5 QB plus 4 QB equals 25,000. So 10 times 2/5 is just 4. So 4 QB plus 4 QB equals 25,000. So 8 QB equals 25,000. And so QB star, I say star because it's kind of our optimal one here, which is this point right here, is equal to 25,000 divided by 8, which is 3,125. You can just use your calculator to get that. So it says 3,125, and that is our optimal amount of B, our optimal quantity of B that we'll consume with these indifference curves and these prices. We can find what the optimal A is then just by plugging 3125 into there. So that means that QA star is just equal to 2/5 times 3125, which is equal to 1250. Right, so here's our optimal B, here's our optimal A, and this is the corresponding point on the curve, which is 1250. Right, so obviously I didn't draw this to scale, but what we've just done is we've taken a budget constraint with prices and income and indifference curves, and we found the point on this budget constraint that allows us to get to the highest possible indifference curve. And just to recap, we did that by finding where the slope of this indifference curve, called the marginal rate of substitution, equals the slope of the budget constraint. That gave us a condition relating A to B, and then just substituted that back into our budget constraint. And that told us at this income level exactly how much of A and B we would consume. So I hope that gave you guys a better idea of kind of how a problem like this is solved, and hopefully some of the background as to why we do some of this algebra here, and what's really going on behind the scenes. So if you have any other questions about this or any other topic, come visit us.